Okay, so for this week our question is, how can you use laws of exponents to simplify monomials? Okay. And the answer is, there are a lot of ways you can use the laws of exponents to simplify monomials. So for today, take a look at all the rules that we have. And we're gonna make a foldable today. And so you need to find this piece of paper. You should have picked it up when you came in. All right, and what you want to do is you want to get your scissors, and you'll notice that it says on this side of the paper, cut on solid lines. Okay, so what I want you to do right now is take your scissors and cut along this line here at the top. Okay, just cut that line. Yes, right now, go ahead and cut that line. Then go down the sides. Okay, everywhere where the blue highlighter is going, that's where you're cutting. Okay, cutting down the sides. And then around to the bottom. Okay, so once you complete that, you're going to fold the paper. Okay, so you're going to fold along the dotted line. So that's here. This is our folding. Okay, and you're going to fold along here. That's our dotted line. That's where you're going to fold along the dotted lines. Okay. Remember, you can pause the video to get caught up. So we have cut along the blue and folded on the yellow. All right. Now that you've done that, I want you to take your scissors again. You're going to pick up your scissors, and you are going to cut here on these lines. So you cut into the fold. Okay. You don't want to cross over the dotted line. You're just going to cut in. You're going to cut along these lines up into the fold. Alright, so we've cut along the blue, fold on the yellow, and then the last thing you need to do is you need to take your glue and put just a few dots of glue along this piece, and you're going to glue this into your journal. Okay, you probably want to pause the video and finish that up. I'll be here when you get back. Okay, so now that you've glued in your foldable, we're going to talk about some of the rules. Okay, one of the rules is about the zero exponent. Okay, whenever you have zero for an exponent, as you do here and here and here and here, okay, whenever you have zero exponent, right, the value is 1. It's pretty simple. Okay, you see 4 to the 0, you make it 1. You have a to the 0, it equals 1. You have negative 3,444 pi to the 0 power, it's still 1. Okay, now the power 0 to the 0 is undefined, so if you come up with 0 to the 0, that one's undefined. Okay, so you want to make a note of that. All right, the other concept we're going to explore in today's work is negative exponents. Okay, negative exponents is the way of writing a reciprocal. Okay, another word you might have seen when you saw reciprocal is they told you to flip it. Okay, and what we mean by that is this is 4 to the negative 2 over 1. That one's understood. And we flip it, and that's the reciprocal. Okay, so the reciprocal, right, is the flip. All right, and notice we went from having a negative exponent to not having a negative exponent. So when you make that flip, that's to get rid of the negative exponent. Okay. Similarly, if I had 1 over x to the negative 2, I could rewrite it as x to the second power over 1, or more simply, x squared. Okay, so it works both ways. Okay. All right, now one thing you have to pay attention to is where is this exponent? And we call them powers, so who's got the power? Okay, it's always very important in life and in exponents to know who's got the power. Okay, so let's take a look at your worksheet now, right? And you'll notice that the negative 4, right, goes with the 4. The negative 1 goes with the entire fraction. Okay, the negative 2 goes with the 8. This negative 2 is for the entire fraction. Okay, and you can see they get a little more complicated as we go. All right. So let's take a look here at number 6, and it got a little bit of complication. So it's got a 0 power, it's got a negative exponent, so we can apply both rules. All right, so negative 15 has no exponent, so I'm just going to write that down, negative 15. Okay. T to the 0 power. Anything to the 0 power equals 1, so we're just going to say times 1. Okay. And u to the negative 1. Right. So it's here as u to the negative 1. It's here on top. So if I'm going to write the reciprocal, right, that's going to be 1 over u to the first power. Okay. And then down below I had 5 u to the third already. Okay, so that's just taking that first step. We used our 0 power and we used our negative 1. Now, I can do some basic arithmetic here. Negative 15 times 1 times 1 divided by 5 is equal to negative 3. So I'm going to write that down, and then I'm going to leave u to the third and u to the first in my denominator. Right now, those are the 2 laws of exponents that we've learned, and I'm going to just have you leave it there. Later on in the week, we're going to learn some more laws, and you'll be able to simplify that even further. But for today, we're just going to stop there. Okay? All right, now, you should probably pause the video and practice some of these and check with your partners and your teacher to find out if you're on the right track on this. All right, so now we're going to talk about the other concept for today is what we call rational exponents. Okay, a rational exponent is a fraction. Okay, and what we know about the fraction is that the numerator, right, is still going to be my power, right? But the denominator makes a radical, okay? And many of you have looked at this as a square root symbol, but its real name is radical, okay? And this little n tells us any number in the whole wide world can go in this little spot. And we can take a square root, a cubed root, a fourth root, a fifth root, whatever number is here, that's how many roots we're taking. Okay. Now I'm not going to ask you to be taking roots and doing all that today. I'm just going to be asking you to be comfortable with changing between a fraction as an exponent to the radical version and back. Okay. All right, so let's take a look at a couple of these. All right, so really simply here, 14 to the 1/2 power. So using what we said before, it's going to be, we do a radical symbol. Our denominator goes in the little crook. Whatever's got our power, our base, right, goes under the radical symbol. And then the whole thing would be to the first power. Okay. No, it looks a little weird. It takes a little getting used to. Let's do one more together. Okay, the 1/2 is with the x. So to rewrite that, I've got make my radical. The 2 goes in the little crook because it's the denominator. The x goes under the radical. The whole thing is to the first power. And this 5, well, it just gets carried along because it's not got the power. Okay. Our other thing we want to do is we want to be able to go from the radical to the exponent form. Okay, so we kind of just reverse the idea. This is our base. What's under the radical is our base. There's no number written here, so it's an understood 2. There's no number written out here, so it's an understood 1. Okay, so that's going to be 17 to the 1/2 power. Okay, that's all you need to do with it. Let's look at one more. 12n, okay, there's no number written, so it's an understood 2. The parentheses are gone, so that means there's an understood 1. And so we rewrite it 12n. And now 12n is under the radical, so it's the whole thing to the 1/2 power. All right, now you need to finish up your worksheet.